Hello all, welcome to video one for section 4.6. I cannot find there it is. Okay, find my whatever this thing is called. Okay, 4.6 rank. So let's let A be an m by n matrix. The rows of A can be identified with vectors in Rn. So, if A is equal to the 2x4 matrix, 1, 2, 3, 4, 0, -1, 5, 9. All we're saying is that these rows are naturally vectors as well. Row 1, you could call it the vector 1, 2, 3, 4, or you could write it as vertically. Doesn't matter. They're both just vectors. They're both talking about the same thing in R4. And similarly, R2. You could write this as the vector 0, -1, 5, 9, or the column vector 0, -1, 5, 9. In either case, they can be identified with vectors in R4. Okay, and so this lends us to this new notion of row space. The row space of an m by n matrix A is the subspace of Rn, spanned by the rows of A, denoted by row A. And the first theorem we have is that if two matrices A and B are row equivalent, then their row spaces are equal. In particular, if B is an echelon form, then the non-zero rows of B form a basis not just for the row space of B, but also for the row space of A. Right, and so the way we typically use this is we row reduce A into its echelon form B, and then use the rows of B to find a basis for the row space of A. Notice this is the exact opposite situation for the column space, where the pivot columns tell you which columns of A to pick for your basis. This is saying throw away the rows of A. We want the rows of our echelon form to span the row space. Okay, so maybe let's write that down to make sure we all got that. So note, so unlike a column space of A, we do use the rows of the echelon form. As basis elements for the row space of A. As basis elements. Or basis vectors is a better word. For row A. Okay. Boom. So let's do an example that'll make this more concrete. So let A be this 4x5 matrix. Let's find bases for the row space, the column space, and the null space of A. Okay. And since we've been doing this for weeks now, I'll let you do the row reduction by yourself. This is just my shorthand for some row reduction happens here, not necessarily 3, it could be a bunch. But it'll row reduce to 1, 2, 2, 3, -1, 0, 1, 0, -2, 3, 0, 0, 0, 1, -1, and then a row of zeros. Right. And this will reduce further if we want the reduce row echelon to 1, 0, 2, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, -1, 0, 0, 0, 0, 0. Okay, so we know, right, from just the regular echelon form, we've got pivot column, and pivot column. So we know these 3 columns form a basis for the column space. Call A as the span of, those first, second, and fourth columns. So 1, 0, 4, -1, 2, 1, 6, 3, and 3, -2, 4, -2. Right? Just these columns. Okay. And this is a basis. Okay. What else do we know? Oh yeah. So we have the right from here we can also pull off a basis for the row space just by taking the non-zero rows. So row of A. It's the span of the vectors 1, 2, 2, 3, -1, 0, 1, 0, -2, 3, and 0, 0, 0, 1, -1. It's also a basis. Okay, if we haven't used the reduced one yet, that mostly we're going to use for the null space. And a perfectly good question is, wait, do these rows form a basis for the row space as well? And the answer is yes, definitely. Okay, so let's sort out a basis for the null space. What do we know? Right, from here we can see that x1 plus 2x3 is 0. We've got that x2 plus x5 is 0. We've got x4 plus minus x5 is 0. Let's write that down. So x1 plus 2x3 is 0. X2 plus x5 is 0. x4 minus x5 is 0. And so we're getting that, x1, x2, x3, x4, x5 is equal to minus 2x3 minus x5, x3, x4, x4 is equal to minus x5. X5 is also free. So it looks like we're getting x3 coming with a -2, 0, 1, 0, 0, and x5, 0, -1, 0, -1, 1. And so the null space of A is equal to the span of these two vectors, -2, 0, 1, 0, 0, and 0, -1, 0, -1, 1. And this also is a basis. Okay, good. And a quick note. So that's the end of our example. So note the row space of A. This is the subspace of Rn spanned by the rows. But we know the rows of A are the same as the columns of A transpose. And so the span of the rows of A must be the same as the span of the columns of A transpose. So actually the row space of A is the same thing as the column space of A transpose. And this is because the rows of A are columns of A transpose. Okay. All right. I think that's all I wanted to say for this first video. So I'll see you all in a sec for the follow-up videos to section 4.6. Take care, everybody.